Good morning, everyone. Myself, Devika, working as assistant professor in the Department of Electrical and Electronics Engineering at Sri Muthukumaran Institute of Technology. Today, we have learned the subject MR3452 Control Systems Engineering for 2021 revisions. Here, we are going to discuss the topic state space analysis. Objective. Understanding the motion of system states and defining state variables and constructing state models, techniques for matrix diagnosizations, and fundamental ideas behind system controllability and observability. This is the state space analysis of this system. So, the input is system described by state variables x1, x2, and xn. This is a system. The input vector u1 of t to ur of t, denoted as the input vector. So the output is denoted as y. Y1 of output vector means y1 y1 of t to common y general term y1 of t. Then terms used in space model. So state overview, it represents a collection of variables that encapsulate the system's past behavior to forecast its future outputs. So the state variable means correspond directly to the number of storage components within the system. And state vector means all the state variables as its elements. So key terms in state space model. Here we have two foundational mathematical frameworks. One is differential equation models, another one is transfer functions models. State variable. It is the minimum set of variables needed to completely describe the system at any time. State vector. When there are n state variables, we group them into a vector. And then state space. It is an n-dimensional space formed by the state variables. Then benefits of using state space models. So it efficiently handles systems and it provides valuable insights and capable of representing the behavior of all dynamic systems, and it allows system analysis and offers a greater precision compared to traditional one. Then drawbacks of the system. It requires more extensive and sophisticated techniques than a transfer function or differential equations. It's a state space model. And that is considered multi-input and multi-output systems having all inputs, m number of outputs, and n number of state variables. Okay. This is state equations. So x I dot of st is equal to ai x1 of t till ain plus biu of v1 of t plus till bin. Then state equation in matrix. So da of x dot is equal to ax plus bu. Then output equation y is equal to cx plus du format in output equations matrix form. So in y is equal to cx plus du. Then state model. State model means we have two equations, both input and output equations is called state model. So with the input equation x dot is equal to ax plus bu, output equations y is equal to cx plus du. So d divided by d x dot is equal to d divided by dt into x of t. So the behavior of x of t to y of t, homogeneous solution of x of t. Another one is non-homogeneous solution of x of t. So homogeneous solution, we are having the solution for state variables without considering the input variables. So this is the state transfer matrix. Phi of t is equal to e power a t. So properties of state transfer matrix, pi of 0 is equal to I, pi inverse of pi of t is equal to pi of t. So x of 0 is equal to pi of t into x of t. So pi of t of k is equal to pi of kt. Non-homogeneous solutions means d divided by dt x of t is equal to a into x of t plus bu of t. So y is equal to cx plus d, the same one. So on conversion theorem, we have to apply the conversion theorem. So this is one of the example problem for linear time invariant system characterized by the homogeneous state equations. So we have to find the state homogeneous state transfer matrix x of t is equal to e power e t. Another one problem based on controllability observability. We know that the controllability formula by using Kalman's test, Q is equal to b a b a square b till a power n minus 1 b. So the QC is not equal to 0, then it is controllable. QC is equal to 0, if it is then it is uncontrollable. In observability, the same by using Kalman's test, Q naught is equal to C transport, A transport, C transport, A transport the whole square, C transport. This from this for, from this by using this formula, we have to find the rank of observability. Q naught is not equal to 0 means then it is observable. Q naught equals 0 then it is non-observable. So another problem based on controllability and observability. Here the state equations are given. So x dot is equal to ax plus bu, y is equal to cx. So we know a, b, c, d. So we have to the controllability by using the formula controllability formula QC. We have to find the rank of matrix. If it is not equal to 0 means it is controllable. Equal 0 means it is not controllable. So this the same one, same controllability, same as controllability. We have to find the observability by using Kalman test formula. Q naught is equal to. So we know A value, C value. So we have to substitute this matrix. Then we have to find the rank of matrix. So here we Q naught is equal to -1. So not equal to 0. So it is controllable. Sorry, observable. So then advantages of controllability and disadvantages. It allows complete control of system, essential for model control techniques. And disadvantage, it requires accurate system model and may need high energy. So application, it is used in robotics, aerospace system, electrical systems, process industries. Then observability. It helps advantages. It helps estimate internal states from outputs, reduce need for multiple sensors. Disadvantages depends on quality of output measurements. Noise can affect. Then applications. It is used in state observers, Kalman filtering, fault detection system, navigation systems. These are the reference for further study. Thank you.